Okay. Hi, everyone. Welcome to our second session of Velociraptor Digging Deeper course. So we're going to start off. This session is really about VQL, the Velociraptor query language. And as we've seen yesterday, Velociraptor is a very powerful tool. We can use it to query endpoints very quickly and do hunts and all this sort of stuff. So, and I've mentioned that VQL is really the most central part of Velociraptor. So it's really important to understand VQL, even if you're not going to really write a lot of artifacts, a lot of VQL detections. It's useful to just know a little bit about it and just kind of understand how VQL works, so that you can do things like post-processing, or you can just adapt existing queries. Sometimes it's easier to just change an existing query. If you sort of understand what it does, then you can sometimes change it very easily to make it do what you want. So we're just going to go into, so this session is divided into two sessions, actually, this module, because we're going to go into a lot of depth to understand VQL. So it's actually kind of, some of it is very sort of theoretical, I guess. And so don't worry too much if it's not really that, relevant for what you want to do. We'll do more we'll apply it more in the next session, the next module. And that's when we get into the real, nitty-gritty of the forensics. So today we're going to go through half of this module, roughly. We'll see where we stop, and then we'll continue tomorrow. Okay, so let's get started, right? So the Velociraptor query language. The first thing that we have to understand is Velociraptor is really all about VQL. So VQL is very central, and it is really the thing behind Velociraptor. So we are actually using VQL everywhere in Velociraptor. We're using it in, obviously, querying the endpoint, but also we can use it to administer the server, to build detections, real-time detections, and also doing some post-processing. What we're going to do in this module is we're going to use the notebook, because that's a very nice way of actually using and understanding and playing around with VQL. So we're going to really use that in the UI. So let's ask ourselves, why should we have a query language? And as you know, I mentioned that yesterday, GRR was one of the inspirations for Velociraptor, and it doesn't have a query language. And the problem with that, what we found, is that it's not flexible enough. When you have a DFIR engagement, you really need to be able to be flexible and change your your query or your detection in response to specific things, new information. So having a query language is actually really, really useful. For example, you get a new IOCs released, someone writes a blog post of a new technique, and then you can easily write some VQL and then hunt for it everywhere. And if the tool allows us to write VQL, custom VQL, and then deploy that in minutes, then we can actually turn around from reading a blog post and thinking about, is a network compromised with this new indicator, or does it have this new technique? And then we can actually check it within a few minutes and get a quick idea, just like we've seen, in yesterday's example. The other cool thing about having a query language that actually implements all of these detections is that we can share them with the community. So all I have to do is write my query and then publish it, on GitHub or in a blog post or whatever, and then everyone else can simply use that and just paste it into their Velociraptor and then check their own network for this indicator. So it just means that it allows us to build a community around the detections. And they can also be customized. So, if I have a particular artifact that is maybe has specific things to our environment, then other people can customize it. Okay, so let's have a look at how Velociraptor runs VQL. There's a couple of ways of running the VQL. You can run it on the command line, just as a command line tool. You can run it via artifacts. We mentioned that artifacts are just a way of encapsulating a query in a YAML file. We can run it across clients and server or inside the notebook. So for this example, I'm just going to show you this very simple query. So I'm just going to tell you this is the hello world of VQL, the very simple, the most simplest thing. And in this example, we are running it, from the command line using the query command, and then we just give it a query. And this is fine. I'll just show you how that works. So let me just start up a new terminal, and I'm just going to go to my downloads directory. And if you recall, yesterday I downloaded the Windows executable here. So I'm just going to use that. And as before, it's the same thing. It's just a binary. Everything is in the binary. So we just have different commands, and the command is just query, select star from info. And that's just a way of running. The -v just prints the logging, so it's a little bit more verbose. But it just basically just runs this query, and then it just prints out the result, which is just a JSON set. And that sort of works, and it's convenient. Sometimes it's useful, but it's not that easy. And especially it gets a bit complicated when you have quotes, because then you have like shell quotes and you have to escape them and these kind of things. It's kind of complicated. So I don't recommend to do it this way a lot. You can do it sometimes, but not a lot. The other way that you can do it is you can actually write artifacts, with Notepad, and then just load them from the definitions flag, and then collect them. Or you can write the artifacts in the UI. We are going to show you. I'm going to show you how to do that. So I'm just going to point it out, and then I'll show you in more details, and then you can just collect them as we've seen yesterday. But the notebook is really the best way to play around with VQL, because it actually has a lot of things that are useful for people who want to write VQL. For example, we have the way that it presents the data is more tabular, and so you can do more things with it. And also it has these command line suggestions, so which really helps. So let's try it. Let's start it up, and we don't really need the server that we set up. Like we're not really building on what we've done yesterday. So if you haven't got through yesterday, then today we're just going to start again from scratch, right? So all we really do from now on, from the rest of the course, is we just use the Velociraptor GUI that we've discussed, that we talked about in the first example. So in the first session, so just running the GUI like that. And as we mentioned, it will just start up a server and a client, and start up locally on our Windows machine. We'll start up a new Velociraptor instance with a username of admin and password of password, right? So that's really all we need to do, because what we're going to do from now on is simply understand VQL and play around with it, and we're just going to run the server locally. So if you guys can do that, I prefer to use the dark mode, but it's just a matter of personal preference. And what I'll do is I'll just also make it a little bit, maybe not, a little bit bigger, so you can see it a little bit better. in the screen share. So again, it just shows us a single server, single client. How do you change the default password? Well, it's a good question. I don't think I showed it yesterday, but I will show it here. So when you create it, so normally when you create it with the GUI, I'll just show you, it says that it created, this is the server configuration file. This is where it is, right? So it is just a normal Velociraptor instance, just like any other instance. So I can just tell it to use that config file. It's just a normal one. And then I can also user show. User-h. Oh, user show username. So I can add a user add, let's say Mike. So the default user that's added is called admin. But now I have to give it a role, -- role, right? Administrator, right? And this is where I add the user. So this is how you set, you can change the password, but just adding the same user again. So and then setting a different password, setting a different role, and so on. So you don't actually need to, it is just a normal Velociraptor instance. It's just, so you can administer it as normally, right? Okay, so yeah, so in here we've got just a single user and a single client that is connected to the server. So it's just connected on the same machine, right? So we can actually collect things from this. For example, I can go over here and collect, let's say, users. So the list of my users on this Windows machine, and it's just going to take 0.08 of a second and do the thing and give me the list of users, right? So I have all my users here, SSH and Mike and so on. So so that's how we collect normal artifacts. But as I mentioned before, these are actually just queries as well. But what I wanted to show you guys is this notebooks feature. So the notebook is a way for us, it's like an interactive, you could think of it as Google Docs of VQL, right? So it's a shared document that many users can use to write VQL together and analyze. So it's supposed to be like, you can actually use it to actually document your analysis process. So let's create a new notebook. So we just click on this and we create a new notebook, and we're going to call it some name, test, let's say, whatever. And if I have multiple users, I can share them. So remember, I created the Mike user and the admin user. So I can actually share it. I'm logged in as the admin, and I can, add a collaborator. And okay, and then I just submit it. So that creates a notebook, right? And you can see that when I click on it, then down here in the bottom pane, I just see the name, right? And so it looks like there's nothing much happening here. And this is something that a lot of people get a little bit confused about, because maybe the UI is not the most obvious straight away. So what we're trying to do is we're trying to create like a document that's easy to flow, that looks a bit, neat. So there isn't really any controls on here, but if you click on one of those, then you get the controls, right, showing up. And that square here, that is called a cell. And the cell is the basic unit of the notebook, right? So when you click on it and it becomes in focus, then you will see that there are controls here that you can, manipulate the cell. So one of the controls here is the edit button, the little pencil, and you can click on that and it pops up a little editor. And by default, the font is very small, so I always prefer to just make it a little bit bigger. And this is the editor like setup screen. for the editor. So you can, change all kinds of settings, but I usually just change the size because it makes it a little bit bigger. And over here, we have the cell type, which can be either Markdown or VQL. We'll talk about that in a minute. And I can also delete a cell. And then when I press this save button here, then it basically recalculates the cell or renders it again. So this is just Markdown. So if you know how to write Markdown, then you can basically go through and do that. Like that's a list item and so on. There was a question. The notebook VQL queries are only applied on the already collected data and also don't ever invoke new queries collections to client. No, that is not true. So what you're running in the notebook is VQL. So you can do anything with VQL, which includes collecting more information from clients or scheduling new collections or creating hunts, essentially everything you can do. So the VQL is a way of driving the entire server. So in fact, the whole GUI is basically driven. Anything you can do in the GUI, you can do with VQL. So it's really just and that's also available through the notebook. So the notebook is really the way that you can like the power user kind of thing, that you can actually administer a whole server through the notebook. But that's a very good question, right? You can do anything with it. And so therefore you need to be, have a higher privilege to be able to use it to create new queries there. But let me show you. So this is the Markdown, right? And I can do all kinds of things in the Markdown. So for instance, I can, I can take a picture like, from here, copy and, and then, paste it. Paste. Oh, it didn't paste the picture, but I can take a screenshot or whatever, and maybe this one, copy image, and then paste it here, and then you can see that it just adds it. So I can add pictures, and that's useful if I want to document. The document here is essentially a workflow. So I get an alert, I'm looking through it, I'm working out what I'm going to collect. And so usually it's quite nice to be able to put like screenshots in here. I accidentally click recalculate. Is there a way to retrieve the results of previous calculation? No, so when it recalculates the cell, it essentially refreshes the contents of the cell. When you launch Velociraptor with the GUI command, I don't see any clients, even though the service status indicates one client. So sometimes this will happen. This is a very good question, because by default, the Velociraptor uses, let me just, it's actually a really good question. By default, Velociraptor uses the temp directory to create this GUI, right? But if when it does that, then the temp directory sometimes gets cleaned out. So files just kind of like randomly get deleted from the temp directory because, it's a temp directory. So if you're going to keep that for any time, then what you really should be doing is creating a permanent directory. So for example, let's say I create notebooks directory, and then I can just use the data store flag to tell it to store essentially the data store in that directory. And so that directory doesn't get cleaned up, like it's not a temp directory, right? And it does the same thing, and it will basically start, from scratch, creates even new keys and new everything, right? So you see, it's completely different, right? It's just like having a completely new installation. They're completely separate. And using this technique, you can actually maintain several completely distinct, separate, Velociraptor GUI kind of setups. So you can play around with different VQLs and save them and that sort of thing, right? So it's just storing it in a completely different directory. Yeah. So that's why. So you see, like, we don't even have the same, the same notebooks or whatever, right? Because really it's completely empty. So if you do that, then the reason that you are seeing the client is sort of like, it's sort of there, but it's sort of disappeared, is because some of the files have probably got cleaned up. And so you can run another interrogate hunt to try and re-enroll the client, and that should fix it. But it's because these these files have been probably cleaned out. Okay, Markdown is really great when you are into the adversary side of it. Oh, okay. Okay, cool. So let me just so this is just a bit of fun here with the Markdown. What you can actually, but for our purposes, what we want to do is we want to create VQL. We want to run VQL. So we're going to click on this plus button here and add another cell. So this is going to create a new cell. And we can either create a new Markdown cell, which this is a Markdown cell, or we can create a VQL cell. So let's just do that. And you'll see that it created a cell here. Please specify a query to run. And so let's edit it. And it's essentially coming up with a new cell, right? And we can see here that the type of the cell is VQL. I mean, you can swap between the different types. It doesn't really matter. But now we are writing VQL. So I'll just get you guys to write the hello world of VQL, right? So so select star from info, and you would have noticed that as I'm typing, you'll see a list of suggestions that come up, right? And that is the So that is actually the so we're going to go into to explain more about the that's why it's really helpful to do that. So let me just run that. Let me just delete this Markdown because we probably don't need it anymore. And okay, and you can see that this is the query. This is the VQL query, and when we run it, then we get the table here, right? So we evaluated the query. So I'm just going to re-emphasize that when you run a query in the notebook here, you are really running it on the server, right? So the server is evaluating this query. In this case, the server is running on Windows, right? It's just because it's the same machine, right? But it will not be the same way when you're running it in production, right? So in production, you're running it on the server again, right? So yeah, so that's the best way that that we're going to be working with today to look at the VQL. Let me just point out some of the GUI things here. So when you run a VQL query like this, then what does it do? A query, just like any other database, for example, simply returns a list of rows. So we have rows. So what is a row? You can see this is a table, and it only has one row here, but this is the row, and you see that each row has columns, right? So it's a table, right? So this is what queries do. All queries return tables. That's just what they do, right? So you should think of a query as just returning a set of rows. But what does it actually look like? If you click on that binocular thing, then it shows us the row response JSON. So this is the row JSON of the data, right? So you can see that because it's a list of rows, then it's going to have a list here, so which is a square bracket, right? So that's going to be a list. And then each row is really a dictionary, like an object, JSON object, with keys and values. And that's really what a row is. So a row is just a dictionary with keys, and each of these are columns, right? The columns are the keys, and then these are the values. So that's really, in a basic level, what a query does. Queries always return a list of these JSON dictionaries, right? So it's important to understand that is conceptually. And then sometimes the tables get like really wide. So, you can actually, turn columns on and off here and, and make them, a little bit easier to see. So that's the column, selector. You can clear them all and just turn on one or two columns so it makes it a little bit easier. And then over here, we can actually export the table. If there's more rows, it's more useful for that. Okay, cool. So that's the VQL. Okay, cool. So let me just go back to the slides. And we talked about how this completes the, it has all this command line completion, which I'm going to use later on to show you how to do the VQL. If you press question mark in any place, then it gives you all the possible completions in that position that can work, right? So for instance, in this case, we're going to give it, we're calling parse-evtx plugin, and then it takes these possible arguments, right? So we've got that. Okay, so we create a local server. We did that. We started up with the GUI. We've done that, and we've actually explained that yesterday. What actually is going on when we do that, and it's the same as running the front ends manually. We added the notebook, right? We clicked the edit button, which allows us to edit the cell, and then the plus button here, which allows us to create a new cell. We added a VQL cell by selecting the VQL here, and that created a new cell with an editor up here, and the table. So when we type our query, it gives us the suggestions at the current position, right? And then so that's basically what we've done so far. So now what we're going to do is we're going to actually understand what is the basics of VQL as a language, right? So the basic VQL. And remember that I wanted to create a language that was easy to understand and very simple. So the language should be fairly simple, but it's not so powerful. Like, I mean, you're not going to write, a new, operating system in VQL, right? It's just not going to work, right? It isn't really that powerful. But what it is very easy to understand, very simple. And there are very simple rules, and we keep the syntax very, very simple. So really, the syntax of VQL is right here. That's really it. So that is the entirety of the syntax of VQL, pretty much. And that is what a query looks like. And what we wanted to do is create a language that was familiar to a lot of people, but not too complicated. So a lot of people know SQL. You learn it at school. It's pretty straightforward. And most people understand select something from something, where something, right? So it's a very simple, very approachable language. But SQL itself is actually very complicated. So this is the basic SQL, right, which most people get. But once you start to have left join, right join, other join, select this thing, select having, then it becomes very complicated, and it's actually really hard to understand. So we wanted to stay away from that. We want to keep it very basic, very simple. And so VQL is a very simple language. And it doesn't have joins. It doesn't have any of the more complicated constructs. It basically just has, this kind of basic syntax. I mean, you can do like group by and order by and things like that. But essentially, it doesn't have joins. It doesn't have any of the more complex SQL constructs. So basically, this is what a VQL query looks like. We have the word select. We have the word from, and we have the word where. And then in between them, this part is known as the column selectors, right? So it basically just selects which columns we want, right? So it's X, Y, Z, right? That's the columns. Then this part, where we would normally put a table in SQL, we don't really have tables in VQL. We only have, we have something called a plugin, because what we're actually doing here is generating rows. We're calling a function here. So we have to be able to provide some arguments. So in VQL, we provide arguments to this, and this is not really a table, it's a plugin. And then we have filter condition. Filter condition is how we're filtering these rows. So there are the three different parts. So let's look at this part specifically. So we said that in SQL, this would be a table, and it would be a table on disk and in the database, right? But we don't necessarily, but in VQL, we don't really have tables, right? We're calling functions. So these are called plugins in VQL terminology. We deliberately don't call them tables because tables suggest it's something static that just has data, but it doesn't really have data. So this is a little bit different from OSQuery because OSQuery, they still call them table, but they're not really tables either, right? So it's a little bit confusing, I thought. So we call it plugins. Plugins are essentially pieces of code that just generate rows. So you think about it, they just emit rows. Rows are coming out of it. And it's the function, so we're calling them with arguments. And then the arguments actually have types. So they could be like strings or integers or whatever. Some of them are required and some are not. And we'll be able to tell which ones are which, from the UI as well. And but then the cool thing about it is that the arguments can actually be other queries as well. Great question. Is there a plugin library somewhere? So yes, so there's references to plugins and also the command line arguments. We'll go through that in this module a little bit later on, but we have references on the website of all the different plugins. And when we said that plugins are generators of rows, well, what exactly is a row? So a row is a dictionary, like we said. It's just a map of keys and values, right? So it's a JSON dictionaries. The keys are always strings, so they're the columns, right? And then the values, they can be anything. So if we look back to this one, look at our row JSON. So you see, for example, that one's an integer, that one's a string, and it can be more complicated than that. It can actually be another dictionary and so on. Is it possible to construct your own plugins? Absolutely, and we're gonna look at how to do that. So you can write plugins in Go to actually add into the project, but we'll look at how to extend VQL in module 7, and there are many ways of extending it that don't require writing actual code as well, right? So, but that's for module 7. Okay, so the values can have different types, right? But they are strongly typed, right? So we don't really like randomly convert between one or another. Yeah, there's the documentation site as well, right? Okay, so let's look at a low level. So this one is actually quite an interesting set of slides, but it's very, very low level, right? So you might you try and visualize what is happening with this query. It's to really understand how VQL works. Then we have to kind of visualize how the rows are actually progressing through the query. So so this is the kind of a pretty central slide, life of a query. And what we're going to do here is we're going to look and see exactly how this query actually works underneath, under the covers. So so it is kind of a little bit abstract, but just bear with it because it is actually kind of important. So so let's have a look at this query, which just says select X from, and suppose there's a plugin that generates a variable called X. And then we have a where clause, and then we say X equals 1. So what is actually happening with this query? So we start off, VQL is going to evaluate this query. So it starts off and it says, okay, you want me to call this plugin. Excellent. So it comes up with this plugin. It passes the arguments to it. So it calls it, right? So there's a bit of code here that's going to run. And that code will generate a row, right? So a row will come out of this plugin and it will go into the query. So you can think of it as like, here's a row that just sort of like pops out of this plugin and it goes into the query. And then VQL is going to look at that. It's going to come from here and look at the column expression. And it's going to go here and it has an expression. The expression is X, right? So what is it going to do? Well, there's two possibilities. It can just look in the row and say, do you have something called X in that row? I mean, and then just immediately resolve it here. But for a reason that will become obvious in a minute, it doesn't actually do that. What it does is it actually takes this row and it wraps around it something called a lazy evaluator. So in other words, it has this expression and it says, I'm going to look at that expression a little bit later. Maybe I'm going to look at that expression later on. I don't know, but I'm just going to remember that I need to wrap this X around this row. So it takes that row and it just says, maybe I'm going to use X, but it doesn't really look at it at that point. It just remembers it. So it's lazy. Then it goes into the filter clause, which is here. And the filter clause is trying to figure out whether X equals 1. So at this point, it needs to know whether X is actually 1, right? So therefore, it has to go back into this lazy evaluator and say, okay, let's pull out this X. Now we're going to resolve it at this point and figure out whether it's 1, and then compare it. And then if it is, then that becomes true. And when the filter is true, then this entire thing is now released, into the, as a result from this query, right? So it comes out of the query. So this is kind of like the general thing. It goes from here to there, and then it gets evaluated here, and then the row comes out. So you might think, well, why is it done like that? It seems like a very complicated way to do it. Why do it like that? Okay, what happens if the column expression and the filter clause uses a different column? Well, that is an excellent question, because this is exactly what we want. This is exactly what we want to do, right? So the idea here is that if the column expression and the filter clause use a different name, different column, then it may in fact be that the row, the entire row, is eliminated by the filter clause, and because it's eliminated, we just don't care about evaluating that. That is why we're using that lazy evaluator, so that we can take a shortcut and we can remove that, avoid this evaluation. If the column expression and the filter clause are different columns, then we can avoid evaluating it. So let's have a look. When you think about it, with VQL, a lot of functions can be expensive. For example, there's a function called hash. So a hash takes a hash of a file. So we can take a hash of a file, and you can immediately see that here you could have select the hash and the file name and other things, and then you might have some expressions here where you have where. And where the size is smaller than 100, and so this example shows us how the row could be eliminated based on here, and then we don't want to actually evaluate that hash because it's not no relevant anymore. So that is why we're using this lazy evaluator. And I know that this is kind of a little bit hard to kind of visualize, so I created a bunch of exercises here, which are very basic, but it really, really helps to understand this kind of lazy evaluation idea. So let me just jump into here, and I'm going to edit this. So here we've got select star from info. Just because there's too many columns, I'm just going to make it select OS from info. So it just selects the OS, so one column. Okay, so this is our basic, query. And what I'm going to show you is there is another VQL function called log. And the log function, you can see it just logs the message. So it just logs a message. So we're going to click that. Then I'm going to press question mark. And I can see that it takes one parameter called message, right? So I'm going to give it rn. Okay, so now we know that. So when I run this, then it's going to log a message. Now you can see here there is the message I ran, right? And that in red here is the log, the query logs. So when the query runs, it can produce logs. So this function, when it evaluated it, then it returned true because the log function always returns true, and and it logs the message, right? So we have this. So this is kind of like how it's a side effect of the function. So what I'm going to do is just rename it. So I'm going to use as to give it an alias. So so just the name of the column becomes a bit easier. So you can see that what happens is info plugin runs, one row is remitted, right? We're going to choose from that row OS and the log, and then the log, right? So then we have one column come back as OS, one column come back as the log. And because we are actually interested in the value here, so we are evaluating this function. And so we can, so we can actually have a real value there. So that's cool. And as a side effect of evaluating this, we're getting the IRAN message. Now let me try and add the where clause here. Where, right? OS. And I'm going to use my matches regular expression. Remember, we talked about that yesterday. Equals tilde is matches. So let me just match with Linux. Now I'm running on Windows, and as you can see here, OS is Windows, right? So what's going to happen now is it actually is not, it's going to eliminate that row because the where is false, right? But the interesting thing is that you see there is no message here. So that function here never ran, right? So it didn't evaluate it. And that is really the reason why we're doing this, this lazy evaluation, because what's happening here is that because the row is eliminated, so the row is, nobody cares about the row anymore. So it doesn't make any sense to get that data out. We don't care about it. So the lazy evaluator around here just throws the result away, never evaluates it. Now imagine instead of log, if this was hash, right? And I did this hash, then it makes sense, right? Because I don't want to do this hash if I don't care about the row anymore. That's really the reason why we're doing this. Can you filter columns not selected? So we're going to talk about that. That's a great question. We're going to talk about that in just a minute, because it's not really about the columns. It's about what variables are available in the scope. Another question, are all the functions part of lazy evaluator, or there are only a few specific functions part of the lazy evaluator? Okay, that's excellent. So the lazy evaluator is not really about the function. It's about the column specification, right? So it's part of the query, right? So when it goes through and evaluates the query, it evaluates everything lazily. So VQL as a rule tries to do everything as lazy as possible, right? And it's not really about the function. So any function would be evaluated in the same way, but it's just basically a strategy of where it can save effort. So because it can immediately eliminate that row, then it can be lazy at this point. Yeah, exactly. Will it hash the file if it's less than 10? So this could be like hash, and then where and size is less than 10. So it's the same idea, right? So if the size is less than 10, the row is eliminated. So if the size is bigger than 10, then the row is eliminated, and it will not calculate a hash. So that's kind of the idea here. So let me show you a couple of more examples of how this works. So we have this, right? So this is where we don't have Linux. Okay, great. So if we said, does it match Windows, right? So yep, so it does, right? So the row is correct. The row is not eliminated, and it's still evaluated. And because we have to get a value for this, then we do actually end up evaluating it, and we get this IRAN. So it does actually work, right? Because we did actually evaluate it. Let's put it back to Linux. But this time, let's do this rule log and OS matches Linux. So what happens now is it going to evaluate it? So the row is still eliminated in this case, but you see it still ran, right? So what's happening here is the filter clause says Well, I need to know what the value of this log is, this column. So what I'm going to do is I have to evaluate it, right? Because I need to know if it's true or not. And it's true because log, happens to return true all the time. So that's fine. And then I have an AND clause, okay? And then I have OS matches Linux, which it doesn't. So this returns false. So therefore, the row is eliminated. But it's already too late because we've already evaluated this thing. So we evaluated it and we return, so it logged, and then it still evaluated the row. Question: how can I know what tables that we have? How did you know that you could select OS tab? So OS is not a table; it's a column, right? And then, but it's a good question, right? There are no tables; they're called plugins. And essentially, you just do it here, right? If you put question mark, then you can see all the plugins that you can use, right? Because after a from keyword, then we can only have plugins, right? So if I choose info, then I know, okay, that's the info plugin. And then normally I will do like star. If I do a star, it will show all the columns, and then I'll be able to see, what you can also just do this. That's a comment character, and then I can see these are all the columns. And then if I look at the row response, then I can see these are the names. So I can use that to tell me what's available to be used. All right. So let's look at the next example. Okay, someone is that's an excellent question. So, if you're getting permission denied on your notebook, that means that your user doesn't have administrator level access, right? So your user needs, as I mentioned before, in the notebook, when you're evaluating the query, you are actually running at a high, you're running the query on the server. So you need to have permissions to actually do this using the ACLs. By default, when you do Velociraptor GUI, it creates the admin user with administrative permission. So if you don't have that, then you can't run new queries on the server, right? Okay, so let me just try and go from here, and let me just swap these order around, right? So if I now do this OS Linux and log, right? So if I do that, then you'll see that it doesn't log anymore. And it makes sense, right? Because what's happening here is the where clause, it evaluates the first thing, it evaluates it in order, right? So the first thing says OS matches Linux, which is false. And then it goes and, so it already knows the entire row is eliminated. So at that point here, it doesn't really care about evaluating this side anymore, because it already false, right? Because it's an and it's false. So it's going to remove that row, and it doesn't really need to evaluate this. And because it's lazy, then it doesn't do anything. So it basically skips that thing, right? So this is actually really important, because imagine that, instead of log, this was something expensive like hash, right? So I have a hash, and if I say something like, okay, only select those files that are, have a size less than something, and then the hash that matches this, then the order really matters. Because if I look at the hash first, then I'm going to have to evaluate the hash for every single file, right? Because it's going in order. Whereas if I use the size first, then I'm going to eliminate the ones that, are too big, and then only hash the smaller ones. So it makes a huge difference to performance. Is there a way to measure query execution time? That's an excellent question. Yes, you just run it and see how long it takes. But also you've got these statistics here, and it tells you essentially how many things are happening, how many rows are evaluated, how many plugins are being called, how many functions are being called. So if you are careful about performance, then you can have a look at this and see, you know, what's happening to your query to see whether it's kind of too expensive, right? Is there an option to select the clients on which these queries will run, or is it being executed a single client at a time? So this is just VQL, right? So this query doesn't run on clients, it's running in your notebook. And what will happen is that, and as we'll see this throughout the course, when we create this is how we're developing the VQL. Then we put that VQL in an artifact, and then we collect that from clients or do a hunt or something separately. So this is just querying. It's just a query, right? So at the moment, the VQL is evaluated on the server, and then we're going to change that to write it in an artifact and collect it. So it has nothing to do with collection right now yet. So we're not really targeting any client specifically. We're just doing it in a notebook on the server. Let me just go back to the slides and go through this example. So again, we looked at the different order, and the order matters, and this is really important. Now, these two functions here are really kind of very critical for this evaluation. So hash obviously is a performance thing, right? But upload, there's another function called upload, which actually uploads the file to the server, and what that does is it actually that is actually really important, because the side effect of evaluating that is actually uploading the file, right? So if you get it wrong, then you end up uploading way too many files, you know, that you didn't want. So that's why it's important to understand, you know, this lazy behavior. Okay, cool. So does that make sense? Yep. So let's move on to the next concept that I wanted to introduce, and that is the concept of scope. So scope is something that pretty much all programming languages have, and it's really a way to understand how names in the symbols in the language translate to actual things. So a scope, in a simple term, is just we call it a bag of names, but it's like a lookup table that looks up names to values, right? So for example, if we have a query like this, which is our very first query, then what will happen is that VQL will start off and you look at this query and say, okay, you're calling a plugin called info, right? So that's what the syntax is telling it. You're calling a plugin called info. But what actually does it mean? What is this info thing? I don't really know. There has to be a way of resolving this name info to some piece of code that will run, right? Somehow it's going to run. And this is what the scope is. The scope is just a lookup between this name to an actual plugin of code that will run. And VQL needs to resolve that at runtime. And then it's going to basically go through and return the row. And the row will come out of this query, again, like we've talked about before, it will come out. And then we have a column selector called OS, right? And at this point, VQL needs to look up this name OS, right? So again, it has to look in the scope to resolve, what does this mean? What does this OS mean? And the way the scopes work is that they are nested. So you have the parent scope, and then you have child scopes that are just like nested. So when this info is run, then it's going to return a row, the row. And then what VQL does is it takes the parent scope. So this is the scope, before the query starts. And then it adds another layer to it, which is the child scope, which actually contains the row. And then when you need to resolve the name OS from that, then what it's going to do is it basically goes through and looks up one level of the scope, and then the next level, and then the next level. It just keeps going up the levels until it resolves the name. So I've got a couple of very simple exercises just to understand what scope means, what scope actually does. And again, it's quite theoretical, but it is actually really important to understand. So let's go back to our example here. And let me just remove that. So here's a very simple, select OS from info. Great, right? So this is a very simple one. But what I'm going to do now is I'm just going to call foo, right? So I'm going to go select OS, foo from info. Now there is no such. Let me just switch to light mode because I think that red is a little bit harder to see. There is no symbol called foo. There's no such thing. So what actually happens is we do end up with a column called foo, but there's nothing in it. It becomes empty, right? And then we are getting this log message. And the log message says symbol foo not found, right? So what is happening here is it's telling us this symbol, I have no idea what this means. And how does it know that? Well, the way it knows that is it has to resolve it through a scope, right? So because it can't find it, then it tells us, to be helpful, what the current scope is. So it says, it just prints out the scope, right? And you can see that the scope is essentially, it's a nested structure. So it has these layers, right? So that's the first layer, and then that's the second layer, and so on. And the very last layer, you can see that it's got all of these, columns in it. That's the row, right? So the row that comes out of info. So it has all of these names. So essentially what it's saying to us is it's saying, I'm trying to get this symbol foo. And so what it does is it works its way backwards from the top, looking, is there a foo in the first layer, in this layer? No. Okay, let's go to the next layer. Is there a foo here? No, all the way until the top. Then it says, I still don't know what this foo is, and I'll print an error and keep working. Now you notice a couple of things here. The first thing is that it doesn't crash, right? The query doesn't crash. It doesn't raise an exception or stop, or it just keeps working, right? But it logs an error, a warning kind of thing. So VQL generally keeps working all the time, right? Even if there is an error in the query, we don't really have exceptions or something like that, right? It just keeps working, but it will print an error, a message to let you know that your query is probably wrong. This could be maybe a typo or something, right? So so that's fine. Now let's do this. Let foo equals 1, right? So this statement here, what it does is it assigns 1 to foo, which is the variable. So now when we run this, it's not a problem, right? It finds it. There's foo. It's 1, right? So that's not a problem. So we don't have any syntax error anymore. But let's now do a bar here. So again, the same thing. And the same thing happens because now bar is not found. But the side effect of that is it's telling us, oh, well, here's the scope, just to let you know, this is the scope. And it's interesting to understand that the top level of the scope, again, is the row. But this time we have one level, which is foo, right? Which is coming from this. So basically, the top part here is from setting up the query, right? So the query is being set up. So these are like, I guess, globals. And then it goes down, and then that statement here, let foo equals 1, creates a subscope where it puts foo in the scope, right? So it creates it here, and then it goes through the next level and the next level. So it just keeps appending it. Yeah. So so that's scope, right? It's again very theoretical. So but why is it useful? Why do we care? Let me just keep that. I'll come back to that. So the reason that we care is that because a lot of plugins use scope in a sort of clever way. That does each let create a level. Yes, exactly. So each let creates another subscope underneath it, right? So when the let is executed, then it creates a level, and then another level, another level. So it's nested, right? It just keeps going down, and then you can refer to it, and then it resolves itself. So let me show you an example for something that is really important, the for each plugin. Now, let me just say that the for each plugin is probably the most useful plugin in VQL. It's probably, you end up using for each in pretty much every single VQL query. Well, maybe not everything, but most queries. It's very, very, very common. And the for each plugin is the equivalent of a join operator. So remember how I said that SQL is complicated because by the time everybody understands the select something from something thing, but as soon as you get to this join, then things become really complicated and it's very hard to understand how joins work. So in order to avoid the whole thing, we just use the for each plugin. So we don't really need to have joins. It doesn't really make sense to have joins in VQL because we don't have table indexes, right? So in SQL, it makes perfect sense to have it, but in VQL, it doesn't make sense. So what does it do? What does this for each plugin do? So the way it works is it takes two parameters. It takes it takes the rows parameter. So there is a question. Plugins such as clients have a column OS info, which prints another JSON. Is there a way to only select some values from the JSON output of the column? Yes, because you just select it, as, let me just create another VQL. So, for example, select star from clients, right? So you're talking about this OS info has a JSON in it. So you just select like this OS info dot, and then if you want like let's say the fully qualified domain name, so FQDN, so like that, right? So it just selects that one value out of it. Yeah. Okay, cool. So let's look at the for each plugin. It will become more easier once we actually start to exercise the exercises, because then you can apply this theory, right? So it has a rows argument, which is a query. So it takes actually two queries. So for each takes two queries. And I think I mentioned briefly that plugins can take queries as parameters, another query as a parameter, not just the normal, not just normal types, right? So it actually takes two queries. It takes the rows and it takes a query. And what it does is it gets a row from from this query, it takes one row out of that, and then it applies the entire query on top of it. So that's why it's called for each, because for each row, then it does the whole query it runs the query again and again. So let's have a look at an example, because it's a little bit easier to understand this example. So let's start off with one query. Select star from, I'm going to use PS list, right, as a process listing, right? Now process listing can take a bunch of parameters, but I'm going to use PID. PID is the process get PID. So this query, get PID is our own process, right? So we're just going to look at our own process right now. Yes, PID is the process ID, right? And PS list is a plugin that lists processes, right? And so it takes one parameter. If you don't give it a parameter, it lists all the processes. But we just, for this exercise, we just want to show one process, right? So we're going to just list this one thing, right? So when we do this, it's going to list our own process. So you can see immediately that here's the name of the process, right? So we are Velociraptor process. That's great. And then you can see a whole bunch of information here that is useful for processes, a single row, right? So which is the process. And what we want to do is we want to let's say we want to know a little bit about the file that came from that process. So the plugin that we want to do is stat. And what stat does is it looks on the file on disk. And if we push question mark, then it tells us, it takes a file name parameter. Okay, that's great. And if we just paste it, oops, that's the wrong one. That's the Zoom link. This one, right? So if this is the file, right? So they are just two separate queries, right? So we have the first one just looks at the process, and then the second one looks at the file name. So like that, right? So it just shows us two different tables. And you can see that here we have the modification time, the full time, and the B time is the birth time when the file was created. So and so you can see that we've basically got two different tables, two different. Well, no, I'm not going to use the word tables because it's not a table, but two different sources of information. The first source of information is the process listing, and then the second source of information is looking at the file on disk, right? And these two. So from here, I want to get the B time, or the M time, for example, and I'm looking at the columns that I want from here, right? So I want the B time, the M time. That's really what I'm more interested in, the file on disk, right? And maybe the full path. And from here, from the process side of it, maybe I want to get like the command line, the executable. So this is the executable, and like other things that that make sense, right? Maybe the name. And so the first thing, it just cleans up the two tables. So I just get rid of all those columns that I don't care about. They're just kind of cluttering up the tables. So I have these two separate queries, but what I actually really want to do is I want to automatically bring the value from here to here, right? Because here you see it's hard-coded. And I just want to look at every process, and I want to pull out this executable. So see, this is the executable here. And I want to take that from here and put it here, right? So this is really what for each is supposed to do, right? For each row from here, so for each row in this table, I'm going to generate a query that uses that in another query. So it generates this table, right? And that is really what for each does. So from for each, right? And then if I use a question mark, then it's a row. So this is the row query. So what I'm telling it is run this query, and for each row that it produces, then the next parameter is query, and you can see this in the suggestion. It's called a stored query, so it's required that it is a query, right? That we're going to run. Right, so we're going to run this query for each row here. We're going to run the query, but now we don't really want this string in here. So instead of having a hard-coded string, we are just going to get that variable from here. Okay, so that that will do the same thing. You can see the full path is already it's just taken from the executable, right? So this exe goes in here. So what is actually happening here? In terms of scope, why did we talk about the scope in order to make this, to understand what's happening? Is this query is basically running. And then for each of these rows, for each row from here, it's going to take these values, name, command line, exe. Then it creates a subscope, and then it evaluates this query on that subscope. So whenever we are referencing the name exe from here, it's actually coming from the value from this row, right? So it comes from here. So that's how we can refer to it from here. And then at the same time, we can also refer to all these other things as well, like the name, command line, all these things coming from there as well. So you can say, here's the command line, which is Velociraptor GUI. That's the B time, that's the M time, that's the full path. So what we've actually got, so this is how for each works. For each just kind of runs the query, and for each row that it returns, then it actually evaluates this entire query. And that is sort of, when you think about it, it's really the same as a join. It's the same as a join, because we're sort of joining from one table to another. If this was a table, then for each row from here, we're joining here. But so that is the equivalent of a join. It's a very useful query. So let's have a look at, again, at how this works. We ran this query, and then from the exe from this query goes over here, in here, and you can refer to it from there. And then this query is evaluated for each row. So now, if we take out this PID thing, right? So it's going to return all the processes. Then you will see that it's basically going through all the processes, right? And then it's pulling the path to the binary, right? And then it's already filling in the B time and M time. So it's basically going through and it's returning 144 rows, right? So it's every process is going to get the exe, and then we're going to evaluate this on each process. We're going to return one row from this one, but for the different exe. And so you can see that these columns here is what's actually returned from the query altogether, right? So coming out of the query. Okay, so for each, is there? So I'm just going to quickly skip over this because this is about performance. So you can actually parallelize it. And this query is really about creating hashes. So remember, this query is how you would calculate the hash. We could just copy and paste it real quick. Copy. Let me create another VQL cell. And I'm just going to run it quickly. And it's going to take some time. Just put it up. Because this is like, you see that it's going to look for, let's just stop it. You can click stop to stop the query, and it will be canceled. So it gets canceled when you click to stop. So this is a glob plugin. Glob plugin searches for files based on what's called glob expressions. We're going to look at them in more details in the next module, but glob expressions are like wildcards, with stars and stuff like that. So this one basically looks at all the files in the system32 directory, and you can imagine that each of those files is returned as one row. So one row comes out. And then we don't want to look at directories because we can't hash directories. So we eliminate directories immediately. And then you can see that we are evaluating the full path and the hashes. So we get all the hashes here from, so this is like a dictionary of hashes. And it basically goes through one at a time. You can imagine, remember that our life of a query, we pull in one row, hash it, one row, hash it, one row, hash it. So it's in series, right? And then this exercise shows us how we can actually use parallelizing to basically break it up. I'm not going to go into too much detail here because it's just a performance optimizations, but you can do run on multiple threads, so you can actually use all the cores and hash, in parallel. Is there a couple of questions? Are any limits for queries inside plugins, functions, like for each inside another for each? No, you can just keep nesting them, right? So you can, there's no limits. Essentially, all you have to visualize that what is happening here is that rows are, and this is again going back to our visualization. The row is going through the query, right? So you can see that the row comes out of here, it goes into here, and then it goes into here, and then we have another query, and that generates more rows. So the rows are just, it's like how rows are flowing through the query. There's no actual limit to the nesting, it just keeps emitting rows. Okay, another question. Is there a way to make the hash the column? Excellent question. So again, what we have here is we have, let me just do a limit. You can also do a limit. So that basically quits after, 5, let's say. So it's a little bit quicker. And you can see that a hash function returns a list, returns a dictionary. Sorry, not a list, a dictionary with different ones, right? MD5, SHA-1, 256. And let's suppose that you only really care about the SHA-256. You don't care about the other ones. Well, then you can see that this is a dictionary. So I can actually access the fields inside the dictionary using the dot operator. So I can go SHA-256, right? That basically text the dictionary dot SHA-256. So that just gives me that. And then if I want to make the name a little bit nicer, then I can use as SHA-256, right? So as is like a column alias. It gives this entire column a new name. And so that's how you do that, right? So it's an excellent question. Is there a way you can match these output hashes with known good and bad? Well, of course, because it's still a query, right? So you can still do where, not is there, and SHA-256 matches, like some regular expression or something. So like that. I mean, this could be the full thing or whatever, right? So, but you got to realize that this actually will be a very bad query, right? Because because it has to calculate every single one to see if it matches, right? So it ends up being a terrible query. But we'll talk about that later, right? Because you'll see that essentially every row has to be evaluated, right? So we just don't know. So what you would really do here is you can actually, maybe you can say, like .png, for example. So you can say like full path matches .png, right? And that will, cause that's much faster. You see how that works? And this is exactly what we talked about with this lazy thing, right? You can see that in action, right? Like essentially what's happening is if we know this is the hash, and then we know that's a PNG file, then if I can match the PNG first and then check the hash, then it's way faster because I'm actually eliminating things much quicker, right? But if I didn't have that, then it will actually go through every single hash, right? And so like now you see, I don't even need to do that limit. It just takes, virtually instantly, because there's not that many PNGs inside this system32 directory. They're mostly executables and stuff. So it picks that one really quick. So this is why, searching for hashing is a bit of an art form, because if you have more information about the file, like even if you had the size of the file that you are looking for, then it's way faster, right? It's much, much better to have a size and a hash than just search for hash without any clue, right? Because when you just search for a hash, it's just too expensive, right? Yeah. Okay, cool. So this is just an optimization thing, and we talked about the lazy evaluator. We sort of touched on the let expression, and I'm just going to show you now let expressions. So we touched on let expression, just kind of briefly introduced it before, but what I want to show you now is that let expressions are they don't just have to be look, before we did something like this, let foo equals 1, that is a let expression, but it doesn't it can be a full expression. It's not just an assignment, right? So it can be like 1 + 1 or whatever, right? But what we can actually do is also assign queries in a let expression. So in this case, you see how we have the for each query, and then we have the query. So there are two separate queries. And they can be very nested. And someone's already asked before, how nested could they be? You can already imagine that you can have a for each inside of for each inside of for each, and it can be very hard to read because it becomes so nested. So what you can actually do is you can use this thing called stored queries. Stored queries are a way of storing the query in the scope, in the scope, right? So it's a variable. So you take a query and you assign it to a variable. So for example, processes equals, so that is one query. So I can take that, put it here, right? And then let's, let's say, times equals, we just call it times or something. And I can take this query and put that here. So at this point, where I'm assigning the query to this process, and I'm assigning this query to this process. So this is, instead of having the query, you see this curly braces just means a subquery, right? But I can just do this here times. So that is exactly the same thing, right? So if I do that, that's the same thing as before, right? What is happening here is that this is called a stored query. So this query is being stored into a variable, and then this query is being stored into a variable. And then I can refer to the query, using that variable name, right? So, but the most important thing to understand here is that it doesn't run the query. It just stores it. So the query itself is not run at this point at all. It just stores it. And it's only run when it's being accessed. So again, it's another example of being lazy. The query is lazy. That is a lazy thing. So it doesn't evaluate it until it needs to, and then it evaluates it. And notice also that over here, this times query, it's evaluated many, many times, right? Because for each row that comes out of here, it gets evaluated one time. So so this is more like a function than so it's more like defining a function than actually assigning a variable, right? It's actually more similar to that, right? So so it's just a way of cleaning up the VQL, so it's not so nested and not so complicated. Yeah, so this is what's happening, right? So we're taking these things and assigning them to here. Okay, so yeah, so we've talked about that. Okay, there's a few slides here to explain the difference between materialized and stored queries. I've mentioned that we don't actually evaluating this query at all. We're just storing it, and then we're evaluating where it's being referenced. Sometimes that's what you want. Sometimes that's not what you want, right? So a lot of the time, sometimes you actually want to evaluate it because you want to cache the results in memory. And so these few slides, I'm just going to leave them here. They make the difference between this operator, which is the materialized operator, materialized let operator. So you can see it says let something, and then it has this less than equal. That means materialized. Versus just equal, which means stored query. So they're just two different ones. In here, you see that this query is evaluated every single time. This query is supposed to match a process name to a process PID, right? And then as it goes through and lists all the processes, and then it matches from process name to process PID, then then that would be essentially listing the processes every time. So it's very slow. But if we use this materialized approach, then it essentially does it once, has a big lookup table, in memory, and then it just quickly matches them. So these are the different differences there. You can also pass variables if you want, and that's a neater way of doing this with passing variables like that. There's a bit here about protocols. I think we can maybe safely skip it. I don't know. So protocols are basically the same as Python. The idea is that in Python, you have a concept of protocols, which means how operators are interacting with types. So, for example, if you try to add, so let me just go back to here. Select 1 plus 1. Now, sometimes this is just as a segue here. One of the syntax in VQL is very standard, is very simple. Select something from something. So there has to be a plugin. We can't just do that, right? That is not valid syntax. It won't let us. It's saying unexpected token end of file, I expected from, right? So it has to be a from here at this point. It's very rigid. So if you don't have something to select from, like there's nothing that you care about here, then you can always use the scope plugin. The scope plugin is like a no-op, basically. It just doesn't do anything. It just returns essentially the scope in one row, which is anyway what it would be doing anyway. So it's essentially a no op. But when we want to use something that doesn't really need us to select from anything, especially, then we can use select something from scope. So in this case, we select 1 + 1 from scope. So, it tells us 2. That's pretty straightforward, right? But if I try to do 1 + a, for example, that doesn't make any sense, right? Because 1 is an integer and then a is a string. So what does it mean? You can't really add an integer to a string. So this is where protocols come in. So basically VQL has a set of rules that say, that tell it like how to actually make sense of the operations. And the addition operation from from an integer to a string doesn't make any sense, right? So it doesn't know how to do that. And therefore it returns null. So you can see it's like an empty string, right? Because it doesn't know what to do. So again, VQL doesn't really raise exceptions or break or stop. It just returns null for that column. This often happens when you do something like, for example, I saw a lot of people doing something like hello matches HE, right? So this is the regular expression operator, right? And hello matches HE, so it returns true. Well, that's great, right? But a lot of the time, people accidentally do something like matches 1, right? And in this case, it makes no sense, right? You can't regular expression match an integer. So that doesn't make any sense. And so it returns false because it doesn't know what it's supposed to be doing here. And sometimes that can be a problem. This happens, for example, from PS list. This kind of query, people often get that a little bit confused when they do something like where PID matches 4, right? This is not going to work because 4 is an integer and the PID is an integer too, right? So regular expression, they're trying to do like a regular expression of an integer, which doesn't make any sense. So it doesn't really know what you're supposed to be doing here, and therefore it returns a false. So this will get you, right, if you make these kind of errors. So just be aware about VQL. Just if it doesn't know what it's supposed to be doing, you'll get a null. And in the case of a where clause, when you get a null, that's a false. So it will eliminate the rows and you'll get no rows, right? Because it will just not make any sense. So, in this case, what people generally want to do is convert the PID to a string, right? And then match on, a regular expression like that, right? So something like that. So it's 436 or 540, like these kind of things, right? So you might have, and then that makes more sense, right? So you convert the integer and then match it on a regular expression. So that makes more sense, right? So this is where we're talking about the protocols here, just to let you know of how this works. You can trace the VQL. I never really do that, but it's possible to trace it at the debugging level. But here we have the references. People asked about the VQL references, and again, it's linked from the Velociraptor GitHub, the website with all the documentation in it. So you can see here the VQL references here, and then all the different plugins and so on. The for each plugin, it explains it here, but probably the most up-to-date reference is actually in the code. We have docs in the directory here, docs, references, and there is a YAML file, which is just essentially, we use that to generate the suggestions from the UI. So it's actually code, it's generated from the code, and it's just a really big YAML file that basically explains all of the plugins and functions. So it's easier to search. Like in here, if I'm going to search for glob, then then it's easy for me to see this plugin, right? Wherever it's mentioned, because it's just a big text file. And then, there's some examples and stuff like this. So I recommend that you look at that file as like the ultimate reference, really, because it's kept up to date more regularly. Yeah, so this is what we're talking about here. Okay, so I think we are almost up to the first kind of, example. Let's do that very quick example where we are going to try and use VQL to write an artifact that detects a specific kind of attack. Now, it's not going to be the most amazing thing, the most accurate detection, but it's going to give you an idea of how you can write VQL to help you detect these things. So what I'm going to do is I'm going to start up another command shell, so cmd.exe, and I'm going to show you guys how to do this WMI execution, right? So this is like a classic lateral movement, but we're going to do it on the local machine. So we're just going to call WMI to execute a command prompt. So what is happening here, we're going to talk about that in more detail about this particular technique later on, but it's calling a WMIC, which is a command line WMI tool that essentially calls the Win32 process WMI object. It has a method called create, so you can create a new process, and we can use that to create another process. And generally, you would use that WMI to create the process across the network, so it creates another command shell here. But let's say that we want to detect this kind of behavior. So how will we do that? So let's write some VQL that detects this kind of behavior where cmd.exe is launched from WMI as opposed to being launched normally. So let's start small. So the way that we would do this, we'll start small. So the first thing is we're going to look at a PS list, and the first thing that I do is just do a limit, right? Because I don't want to see all the processes. I just want to have a few, so just to see what columns are available. So the columns that are available that are going to be interesting to me is the name, and then I have the PID and the parent PID. So PID and parent PID, right? So these are the process IDs, the name, and then I've got the command line and the executable, right? So command line, and especially PS list is actually giving out a lot of information. We might want to have the other information, but for now, this is probably enough. So let's look at the first 5. So it cleans it up a bit, right? So we don't have so much clutter. And then we have the PID and the parent PID. So that's the PID and the parent PID. And we really care about command prompt, right? So we can immediately just look at our command shell. So command line, or we could even use the executable matches cmd.exe, right? So I'm going to look at, so this will basically show me all the command shells on the system, right? So it just filters the process listing, right? So I've got the PID and the parent PID, and let me just do that WMI thing again, so I can see that child process. Refresh, so it will recalculate it. And you can see that it's actually quite an interesting thing. You can see, you can already see it immediately, that the parent process for most of the other things, it's the same PID, but then for this one, it's actually a different PID, right? So I want to know what that PID is, right? So I can also, so let me just use a subquery to figure out what the PID is. Select name from PS list, and it takes a PID or a parameter of PID. We've seen that before, right? It takes a parameter of PID, and it's just going to show us the process name. And so now well, just for each row that matches, right, from the PS list, we're going to run a subquery for that row, right? So for that one column, it's going to have a subquery. So let's see how that looks like. So we have a subquery. This is a subquery. So it runs it again and again and again for each row, right? And it's going to look up the process for each row and just tell us the name. So you can see immediately that this is already unusual, right? Because this one is coming from the parent is WMI server, the WMI process server. So that is strange, right? Straight away, we can say, hey, that is weird. So I want to turn it into a detection. So I can immediately filter. So here, this is the subquery as parent name. I just want to make sure that I don't have like a weird column name. So I'm just going to rename the column, right? So do that again. Okay, so this is the parent name. And I'm going to go and parent name matches WMIPRVS, like that, right? And that would be that would be suspicious. So you can see that all of a sudden I have a query that is now going to return, if this query returns any rows, then that's suspicious, right? It represents this behavior that I'm talking about, the WMI. So this is the first example. We're going to stop here because I want to show you how to convert that into a detection. And this is okay because, in this module is split into 2 sessions. So this is part 1, and then tomorrow we're going to do part 2. So we can see how we can create that PS list. And then we can, tomorrow we're going to turn that into a detection and a hunt and run it everywhere. So I want to show you how to go from a VQL in a notebook all the way through to a full-blown detection. So I think this is a good spot to pause now, and then we'll continue from tomorrow. And we're kind of out of time. So if you have any questions, let me know. Send me emails or go on Discord, and I'll try and fill them. And we'll see whether we can probably edit this video from today and post that up on the YouTube again. So I'll see you guys tomorrow. So there's a question: can we have this query every 5 minutes or something like that? Absolutely. So we're gonna see how we can turn that around. The Discord channel is linked from the GitHub. So you can go to the GitHub page, and at the bottom of the README, there's all the links here for the Discord and mailing group and all this kind of stuff. Cool. All right. Thanks, guys. Thanks.